So far, all the algebra we've seen has been fairly devoid of context. It's just been algebra for the sake of algebra, manipulating these letters, which of course are always standing for a particular number, manipulating them in different ways, running through these different keywords to give us the tools we need to be able to work with this setup. But that then begs the question, what's the point? What is algebra actually for? Well, think back to when we first started looking at algebra, and we started with this question. In this question, we had the information about the shopping. We were looking at the prices of some carrots and some bananas in a shop. We started with some information that we knew, in this case the total cost of the shopping and the cost of one banana, and we went through that logical process. Even if we didn't necessarily realise we were doing algebra at the time, we went through this logical process to work towards a piece of information that we didn't know, the cost of one carrot, and that is what algebra is for. In fact, that's what algebra is. Algebra is starting with information you know, going through a logical step-by-step process to get to some information that we don't know. The use of letters and the different tools that we have, things like the expanding, things like the solving, the factorising, and all those others, the simplifying as well, they are just aids to us working with this setup, this idea of getting from information that we know to information that we don't know. So what happens when we put some context in? Sometimes what you're going to need to do is solve a particular equation to find an unknown value, but it will be one that comes from a question that's actually been written out, an actual real-life problem, as much as any problem in the GCSE maths exam is ever going to be real life. We'll start with a simple example, one that we've seen very similar to before. The idea being, with any of these questions, you will be given some words. You will have to first of all write an equation for it and then solve the equation. In order to actually get the question to a point where we can solve it, where we can have an equation that we can then work with, we can follow the same basic steps each time. Step 1, we can ignore the algebra. We can just look at the words in the question or the diagram. We can pretend the algebra isn't there. And we can do step 2. Step 2, we can look for key words in the question or think about key facts that might help us. And we can ask ourselves, what would I do if there were numbers here? Actual numbers, not just letters representing them. Would I add stuff up? Would I times things together? Are there certain facts that I could apply that might be useful here? Which then brings us to step 3. Once you've decided what you would do if they were numbers rather than letters being used as a code for numbers, step 3 is to actually do that with the algebra. If your answer to question 2 was add them all together, then add all the algebra together. If your answer to question 2 was times two things together, then step 3 would be times those two bits of algebra together. Actually do what you decided you would do for numbers with the algebra, and then set it equal to something. You need it equal to something to have an equation that you can solve, otherwise it's just an expression, a meaningless bit of algebra. Once we set it equal to something, we are left with an equation that we can actually solve and work out the value of this missing letter. It might be that you're given the total or the answer, the thing that you're setting it equal to, in the question. It might be that you have to use a fact to work out what it would be, but somewhere or somehow it will be obvious what you need to set it equal to. Step 4. Once you've written that equation, you've got some algebra equal to a certain number, then actually solve the equation using whatever method you normally would to solve an equation of that type. If the equation is one that you would solve with a function machine, then solve it with a function machine. If the equation is one that you would solve with scales, then solve it with scales. It will generally be one of those two things. It is very unlikely to be a quadratic, although it could be. You could end up with a quadratic out of one of these, and you may have to solve it using the method of putting it into the two brackets, factorising it, and then setting it equal to 0. It is possible, but very unlikely. Generally speaking, the skill they are testing here is whether you can write an equation and then solve it, whether you can turn words into proper symbolic algebra. So they will generally be function machine questions or scales questions. And then step 5, the final step, is see what the question needed us to find. Is it enough that we've got the value of this letter in the question, whatever we set as the unknown letter, or do we need to put it back into the context? Do we need to work out several pieces of information with it, or do we just need to give the value of the letter? So, on to our first example. We've seen these kind of questions before. I think of a number, multiply it by 12, and add 3. My total is 27. What was my number? And we saw these when we were setting up this idea of the function machine, but it gives us an idea of how we might start to turn words into equations. I think of a number. Do we know what that number is? Well, no, we don't. But by the time we get to the end of the question, we need to have worked it out. So I think of a number. Well, let's give that number a letter. That is our unknown thing that we are trying to find the value of. So let's choose a letter to use for my unknown number. And I'm going to choose X because it seems like a sensible one to choose. We generally go with X's. It's a fairly common one. So let's call my number X. I multiply it by 12. Well, if I have 12 lots of that, I have 12 times X, or I end up with 12X. And then I add 3. Well, that will be 12x, add 3. So, step 1. I ignore the algebra. Well, I think of a number, I times it by 12 and I add 3. I then need to put some algebra in, and there was my algebra. My step 2 was the multiply and the add. And then my step 3 was doing that with the algebra. So I said, there is some algebra now. I'm going to times it by 12. I'm going to add 3. And I now need to set that equal to something. I look through the question. Is my equals something given in the question, or do I need to use another key fact? Within the question, it says my total is 27. So I can set that equal to 27. And there's my first 3 steps done. Step 4 then is solve to find the value of x. So I now need to solve this question. This is just a standard function machine type question. So I'm going to build my function machine going forwards. I start with the x. First thing that happens is we times it by 12, and then we add 3, and that spits 27 out the end. 27 goes back in. Instead of adding 3 when we're going backwards, we're going to be taking 3. That takes me to a 24. And then I'm going to divide by 12 to get 2. And I'm saying that my final answer is x equals 2. Should probably check that. Well, 12 times 2 is 24, plus the 3 is 27, so that works. Final step, I need to look back in the question to see what exactly I need to give as my final answer. Well, the question said, what was my number? I used x to stand for my number. I have found the value of x. I have found my number. I have found everything I needed to find for this question. Now this question is a lot more like the type we'd commonly get. Sam has some money. Tom has twice as much money as Sam. I would say Tom is a real person. That's never going to happen. Sam has some money. Tom has twice as much money as Sam. Nadia has £3 more than Tom. If they have £58 in total, how much money do they each have? Now, granted, there is nothing in this question that says this is an algebra question, but Sam has some money. We don't know how much money Sam has. That is the unknown. The amount of money that Tom has hinges on the amount of money that Sam has. And the amount of money that Nadia has hinges on the amount of money that Tom has, which hinges on the amount of money that Sam has. So really it all hinges on that one unknown at the start of a question. And if we have an unknown value that we need to find to work out all the others, that then suggests we need to use some sort of algebra, because we could easily write a code for the amount of money that Sam has. However, we're going to go through those steps. So step 1, we're going to ignore the algebra. And then step 2, we're going to look for keywords in the question, or we're going to think about key facts that will tell us what to do if it was numbers. We're going to ask ourselves, what would I do if these were numbers? Which, of course, they are ultimately. Well, if they have £58 in total means that we need to add everything up. So let's write a bit of algebra and set it equal to something. So, let's say Sam has some money. But why don't we say that I have X amount of money? X just standing for the amount of money that I have. Could use any letter, could use S, but I'm going to use X. Tom has twice as much. So Tom will have 2 times X, or 2X. And Nadia has £3 more than that. So she has 2X, and then plus 3. Not 5x, notice it's 2x plus 3 because the plus 3 and the 2x will not combine. They are two different things. Now we said that they have £58 in total, and that word total is key. Total means that we add everything up. So let's just add these up. There's our step. We need to add up x plus the 2x plus the 2x plus 3. 1, 2, 3, 4, 5. That comes to 5x and then a plus 3. And there is our total. 5x plus 3. We then need to set it equal to something, because that's just an expression at the moment. If we set that equal to something, well, what's that equal to? That is the total worked out by adding these up, but the total is also £58, because that's what we're told in the question. So if the total is also £58, those two things must be equal. 5x plus 3 equals 58. There is an equation. We can solve that. And again, this is a nice, straightforward function machine type question. So let's solve that equation. So our question is now solve 5x plus 3 equals 58. We start with the x. We're going to build our machine going forward. So the first thing that happens, it becomes a 5x, so we times it by 5. And then we're adding 3. And that spits out 58. Reversing our steps, 58 goes back in, we send the machine through backwards, the add 3 becomes a take 3. And that leaves us with £55. The times 5 becomes a divide by 5 when run backwards, so we end up with 11, and we're saying that x is £11. Or just 11, in fact. We could probably check that. 5 lots of 11 is 55, plus the 3 does give me 58, so that is okay. And there we have it, we've done the question, finished. We've found the value of the missing letter. Or have we? Because we need to make sure that we do step 5, and step 5 is check the question to see what we need to work out. And the question says, if they have £58 in total, how much money do they each have? We have only got one answer at the end, and really we should have 3. The amount of money that Sam has, the amount of money that Tom has, and the amount of money that Nadia has. So we now need to use this, go back to our original setup, our original algebra that we wrote, and work out the value that each of them have. So if we think back, Sam had X pounds, Tom had 2X pounds, and Nadia had 2X plus 3 pounds. If Sam had X pounds, then Sam had 11 pounds, because we've just found that the value of X is 11. Tom had twice as much, so he must have had 2 lots of 11 is 22 pounds. And Nadia had 3 pounds more than Tom, so she must have had 25 pounds. Final thing we should do, we should probably check that that actually works within the question. Well, we knew from the question that they have £58 in total. If these three add up to 58, there's a good chance our question is right. The chance of 11 being wrong and these still working out to be 58 is very, very slim. So 11 plus the 22 takes us to 33. 43.53 plus the 5 is £58. This all works. Everything makes sense within the question, and we get the total that we needed. So Sam has £11, Tom has £22, and Nadia has £25. Now, often in these questions, there's going to be some sort of clue word in the question. It'll be something like total, or difference, or perimeter, or area, or something that will give you a good idea of what you need to do. If you see the word total, you're probably going to be adding something up at some point. If you see the word difference, you're going to be taking something away. If you see perimeter, well, you know how to find the perimeter, so you just add all the sides together. If you see area, well, it depends what shape it is, but you're going to be multiplying some stuff. You might be dividing by 2 if it's a triangle, say, but if you see the word area, you know what to do. You know how to work those things out. And sometimes, though, there's going to be even less information than that. There isn't really going to be a clue word, like in this question. All we are told is that there is a triangle that has those three angles, 3x for the angle at the top, 2x plus 10 for the angle bottom left, and 5x minus 30 for the angle bottom right. They are all numbers. X is a number. We know that because the question says for some value of x. So x is a number, which means 3x is also a number. 2x plus 10, 2 lots of that x plus 10 must also be a number, and 5 lots of that x minus the 30 must also be a number. So there is a triangle that has those three angles, and we need to work out the value of x, and that is the only information we are given. Because sometimes we have to use not clue words in the question, but other facts that we know. We have to apply something that we know, and it is often shape questions that they'll do this for. There is some other fact that we have to pull out of our heads and use to unlock what we do in this question. If we ignore the algebra for a minute and think about everything we know about the angles in triangles, hopefully one key important fact jumps out at us straight away. And that fact is that the angles in any triangle will add up to 180 degrees. If we take the three angles and add them together, we should get 180 degrees. There is our key fact. So that's steps 1 and 2. If we ignored the algebra and we just had numbers, then we would add them together and get 180 degrees. Well, there's our step 3 then. We need to do that. That's what we need to do. Let's add these three angles together. So if we take the first angle, 3x, and then we take the second angle, 2x plus 10, and then we take the third angle, 5x minus 30. If we add those together, there's our 1, 2, 3 angles. Add those together, they should equal 180 degrees. Well, fine, all well and good, but that's quite complicated. Maybe we could simplify that down. Maybe we could collect together stuff that will collect together. So we might want to start at the right-hand side, box stuff off. The 30 and the minus, the 5x and the plus, the 10 and the plus, the 2x and the plus, and then the 3x at the front. I'm going to move all of my x's over here. So over here we're going to have the 3x, we're going to have the plus 2x, and we're going to have the plus 5x. And over here on the other side we're going to have the plus 10, and we're going to have the minus 30. I'm going to collect those together. I'm going to collect all my x's together, I'm going to collect all my numbers together and then put them back together at the end. Well, over here we've got 3, 4, 5, 10x. And over here, we've got a plus 10 and a minus 30. Plus 10 minus 30 will take us to minus 20. So there we go. 10x minus 20 if we simplify. And we said before that the whole point of us adding them together was so that we could then set them equal to something. And we said that if we add the three angles of any triangle together, add these together, we get 180 degrees. So if this is equal to 180, then so must this be, because they are the same thing. And there, at the bottom, 10x minus 20 equals 180 is an equation that we can solve. So that takes us nicely to step 4. where we actually solve the equation. And again, it's turned out to be a nice, straightforward function machine question. Again, remember, sometimes it'll be a function machine question, sometimes you can end up with a scales question. Generally speaking, actually, it will be a function machine question, because what they're really testing here is not can you solve an equation, but can you write an equation from some words or some pictures. So if we clear this, we will solve the equation and then find the value of x in this question. So the question has now become, solve 10x minus 20 is 180. Numbers are bigger, but that's okay. We're dealing with 10s and 20s, it's not that bad. We're going to start with the x, we're going to times it by 10, that's our first step, and then we're going to take off the 20, and that gives us the 180. So there's us building the equation going forwards. Reversing it, 180 goes back in, we're going to add 20 this time, and we're going to divide by 10. Adding the 20 will take us to 200, and divided by 10 will take us to 20, and then I reckon final value x equals 20. 10 times the 20 is 200, take away the 20 is 180, and everything works. Final step, we need to check back in the question and make sure that we have found exactly what we need to find. Was it that we were looking for the value of x, or was it that we were looking for the 3 individual angles? Well, if we look back at the question, it simply says work out the value of x, and that is the only thing we need to do. So our final answer can be x equals 20. If we wanted to check that that was sensible, well, I suppose we could work out the 3 angles, and actually just checking that it is a sensible answer and that it does work might not be such a bad thing to do. You don't necessarily have to write this down. I'm going to. You could just do this in your head just for context. The angle at the top, 3x will be 3 lots of that x is 60 degrees. That's okay, that's sensible for a triangle. 2x plus 10, well, 2 lots of that x will be 40, plus the 10 is 50 degrees. That's also sensible for a triangle. And the third angle, 5x take 30. Well, 5 lots of the x, 5 lots of the 20 will be 100. Take away the 30 is 70 degrees. That's also sensible for a triangle. You could have a triangle with angles of 60, 50, and 70 degrees. That would be okay. And if you add those 3 together, 60 and 70 gives you 130, plus the 50, 180, and everything works nicely. But all we needed to do was give the value of x. So there is our final answer at the bottom, x equals 20.